Hello, welcome to Better Together with Shinrai Sensei, and this is another short form video on math. Today we'll go over another few definitions that will help us in some future examples of problems and such like that will hopefully get you guys a better understanding. We'll show you what some symbols mean, as well as getting you basic definitions for things that will come up in algebra, right? Alright, now up here are just some equivalency symbols that will help show you. So, x and y, just variables, which are symbols in place of an unknown value, right? So I don't know the value of x, and I don't know the value of y. But these symbols can help you come to a determination on the values and how those values correlate to each other, right? So sometimes these symbols on their own can help you get a little closer to the answers of the values that these symbols, variables represent. So, in the top left corner, we have the standard equal sign. Everybody's I'm sure, has seen this at some point in their life. Okay? Then you have right below it, not equal. So the equal sign having a slash through it is the standard for showing that something is not equivalent. So x equals y, and the inverse statement of x does not equal y. Now, these symbols are inverses as well. In this case, x is greater than y. Don't ask me why. But in this case, x is less than y. Right? Now, if you see this greater than or less than symbol with a line underscoring it, then now instead of simply saying it's greater than or less than, now it's saying it's greater than or equal to, or less than or equal to. So it changes the dynamic entirely, right? So in this case, it's x is less than or equal to y. And in this x is greater than or equal to y in the top right corner, and then x is less than or equal to y in the bottom right hand corner. All right? So there's just some symbols, help you kind of understand some things maybe in the future. Now, the best thing to know about expressions is a math problem that doesn't have an equal sign, right? So, for example, so let's say 7x plus y. This is an expression. But if I say 7x plus y equals a, that is no longer an expression, that is an equation. Because now there's not just a closed operations going on here, closed series of operations. Now the equivalency is drawn between something. And so that's really all an equation separates. That's all that separates an equation from an expression. Equations have something to do with equivalencies. Expressions are simply there to express mathematical functions, right? But like I said, really the difference between these two things can be boiled down to is one got an equal sign or equivalency sign, so equivalency symbol, equivalency symbol, no equivalency symbol, right? It's not just necessarily the equal sign, because an equation can have like a greater than or equal to, or less than or equal to, or less than, greater than, any of those, right? But once you equate two different expressions, well, really an equation is just connecting two different expressions. Okay? Now, going down right below that, we have properties, and a property in mathematics is something that's always true, right? So anything times 1 is itself. Anything plus 0 is itself. Anything times 0 is 0. there is nothing, there's no value to anything that is going to be divided by 0, because you can't divide a number by 0, right? These are all properties of mathematics that are 100% of the time absolutely true. No matter what you do, they're always going to be true, right? Now, 3 more terms before we end this particular lesson. You have terms, you have coefficients, you have constants. We've already discussed what a variable is. In this case, the variable is a. But the terms, anything that is an operation sign, so plus, minus, multiplication, so, times, divided by, any division, anything like that. Division, roots, exponents, addition, subtraction, all that stuff. Anything that is on separate sides of that operation is a term, right? So if I have, in this case, 7a plus 6, 7a is a term, 6 is a term, because they're on the opposite side of an operation, right? Now, a coefficient is a number being used to change the value of a variable, right? So you don't know the value of the variable anyway, and you're trying to change it. Now you have a coefficient. So 7 is the coefficient in this problem, because you're multiplying the value of something you don't know, which is a, by 7. Then plus a constant, which is something of fixed value, right? And that's what numbers, alluding to our first episode when we talked about how math is supposed to be a description of reality, and that's why we can do certain things with mathematics that on paper, really we shouldn't be able to do math and have things that don't make sense in the real world. But when you start to do abstracting, that's when you start to see these issues pop up. But math is always supposed to be about describing and quantifying reality and real functions that you can observe every day. So I am not sitting here saying I've got, 30 of these books and I need to lose 28 of them in order for me to be able to carry those last couple books across, the country. How many books do I have to carry across the country? Well, it's 2, right? These are descriptions of real things that we're using math to explain. And so that's what constants in math are. You are describing something real, finite, definable. You don't have to sit here and play a guessing game about a constant. You will always know that that constant is going to be a certain value. Right? Whatever value it says, it's a constant. In chemistry and in some physics stuff, some constants are so long that they don't really choose to write them as a number. They choose to write them as a variable. But in this case, the variable isn't an unknown value. It is a known value. It's just shorter to write the variable. That's kind of like what we have with pi, right? Pi has a known value. Whether we acknowledge it as being finite or infinite, whether we acknowledge it as being rational or irrational, pi has a finite defined value. And so, since we just have a difficult time writing it out to its fullest extent, we just shorthand it to the Greek character pi. But pi is still a constant. So even if you see a problem where I'm trying to write out, let's say the circumference of a circle, right, is equal to 32 times pi. Let's draw a squiggly line here to make sure that these don't get mixed up here. So the circumference of the circle is 32 times pi. That is a finite value that I can find by doing this. So this equation is pretty simple because these are 2 constants. that I'm multiplying together. Even though this is a variable, for all intents and purposes, this is a variable because I am choosing to use a symbol to represent a number. And the number can be known or unknown, right? So symbols in place of known or unknown. I should correct this. Known or unknown. So variables are symbols in place of known or unknown values, right? I'm using pi symbol in place of the pi number because of pi's irrationality. And, you know, it's kind of like a crazy X. But I'm using pi in place of the number that it's supposed to be represented by because the number's irrational, like your ex-girlfriend. And I just use that symbol to make it simpler for myself, but this is not a variable. In any way, it's not necessarily a variable because its value is constant. Right? So, really, all you need to know about constants is their value is constant. The value is defined for a constant. Whether it be you're substituting Avogadro's constant in or the mole in chemistry, you know, whether you're substituting those numbers in for their constants, they are still a constant. They represent them with Greek symbols, but they are constants. So just because it's represented by a variable, well, really the only time it's a variable is when it's an unknown value. Because that's kind of why it's called a variable. It's called a variable because the variability of its value. You don't know what its value is going to be until you solve for the variable. And in an expression, you can't solve. You cannot find the value of an expression. It's not until you create an equation that you can find the value of a variable. And that's also dependent on how many variables there are and how complex the operations get to be that involve that variable. But the other issues that you can come into that are that variables, since you can have a known value for that variable in there, if you if you solve for variables without substituting their values in, you can create a equation that is falsely equivalent. So I can write an equation that says 7x plus y equals, let's say, 23, right? And through some means out there, I could eventually draw that x and y. If I did the math in a certain way, I could probably get y and x to be equivalent values, even if, let's say, whoever suggested that I use x and y knows that those two are not equivalent. On paper, I can prove them equivalent. So this is the issue that we have when we don't substitute the variable in first. In our order of operations for algebra, really the first step should be substituting any known values in for the variables, right? But for today, I think that that's a very good place to stop. We covered equivalency symbols, expressions, equations, properties, terms, coefficients, constants, variables, and gave you a couple examples of equations, expressions, variables, and constants, right? If you guys have any questions, please feel free to drop a question at the tag on Twitter, Shinrai Sensei, or on my Twitter account. Mention me at my Twitter account at Shinrai Sensei 15, or please leave them in the comments section. I look forward to any interactions with you guys that I have, and I hope to see you all in the next episode.